In this video, we're going to cover the addition of a halogen to an alkene. So I'm going to start with this cyclic alkene, cyclohexene, so we can demonstrate the stereochemistry of this reaction. If I react this with a halogen, so in this case I'll use bromine, Br2. It also works with chlorine as well. What I'm going to get in this reaction is a dibromide where the two bromines are on opposite sides of the ring from each other. Okay. So that's going to be the product. And let's see how this reaction takes place. So I'm going to redraw the material here and go through the mechanism. So bromine, very interesting compound. The bromine-bromine bond, they're both electronegative elements, and to be in a bond, they would rather not share. One would actually want to have that negative charge. So what happens with Br2, it actually reacts as a very good electrophile. So a bromine plus and a bromine minus are formed in this reaction. So the double bond attacks one of the bromines, right? And that breaks the bromine-bromine bond. But one of the lone pairs comes in and forms that bond. So what we're doing is we're making a three-membered ring with bromine, which seems really strange. And it's a positively charged bromine. But let's take a look at that. What happens here is they both have to come on the same face. So I'll draw it on the bottom face. Actually, both sides are formed. And I'm going to draw this as a plus charge, and I'm going to have two more lone pairs on that bromine. All right. So we have a bromine that's still positive, and we also get a Br minus that comes off with all its electrons around it. Now what happens from the opposite side, so SN2 reaction, the bromine attacks and gives those electrons back to the bromine. And what that does is it has to attack from the opposite face, so the bromine coming in from the Br minus comes from the top face, and that bromine winds up going behind to give the dashed line. Okay. Again, the trans stereochemistry is important to remember, and this three-membered ring, bromine intermediate. This isn't just some crazy thing that gets drawn. This intermediate was actually isolated for a few of these in this reaction. It's a proven intermediate for this reaction, and it demonstrates how the stereochemistry becomes trans to each other, where the bromines are on opposite side of each other.